So I want to start talking more about ActionScript programming again, and I want to start by talking about one of the basic building blocks of ActionScript programming, which is something called variables. You may have come across variables in mathematics. These are numbers which are represented by letters and can take any value. In computer programming, it's quite similar. Variables are data represented by a specific variable name that you give it. The one difference between computer programming and mathematics is that variables can only store specific types of data. So you set a type of data, and a variable can only store the type that you set it to store. As I mentioned, variables are identified by a name, and that is a case-sensitive name. So if you give it a name, you cannot change the case of the name that you've given it. And as I mentioned, the name and the type of the variable are set by the programmer. So let's look at an example. This is the int variable, which can store whole numbers. So 0, 1, 2, 3 and so on. Also negative numbers, these can be stored inside an int. And the way to declare an int variable in a program is as follows. You use the var keyword, var, all lowercase, then you give it a name, in this case myInt. By convention, I've used a lowercase for the first word and an uppercase for the second word. I would also use uppercase to start the words if I used any more words inside this name that I've given it. But I've used just one, so I've just made that I capitalized. Then I've put a colon in, and then I've put the type of variable, which in this case is an int. And this syntax is very, very specific. You'll see it all the time. It's always the same. So you've got var, the variable name, the colon, and the type. After that, it's completely flexible. So you'll see all kinds of different things used afterwards, which is the instantiation of the variable. So that's the declaration of the variable. You give it a name and a type, and you're saying it's going to be used in the program as a variable using the var keyword. Then there's the instantiation, which is storing something, or perhaps not storing something, inside the variable, and that can be very flexible, very different for different types of variables and different types of circumstances in computer programming. So that's one way of setting up myInt. Another common way of doing it is to just declare it without storing anything inside it, and then instantiating it, storing something inside it separately on another line somewhere else in the computer program. So let's have a look at actually declaring an int variable in a real program. So this is a Flash program I've set up with a text box here. I've called that output text, the instance name, so I can refer to that in ActionScript. Inside the timeline, I've set up an actions layer, wrongly in fact. Let's put actions, and let's put layer 1 there. That's fine now. So I've got my actions in that top layer. I'm going to put window actions to see that. And you can see how here I've got my var keyword, my variable name, my colon, my variable type. I've instantiated it in the same line as I've declared it, and then in the output text we're going to see the output of that variable, and I'll say what I'm doing with this string later on. For the moment, don't worry about that. Another way of more commonly doing exactly the same thing is to use the trace function, which we've used on many occasions, and that just prints out what's inside the variable to the output window. In this case, I'm putting the variable output to a text box. So let's test that. So it's just reading 0, which is what I've stored inside the variable. And if I changed it to a 1, the output text will change to a 1 as well. If I declare it and instantiate it on a separate line, that should work. There should be no problem there. Yep. What happens if I just instantiate it? Sorry, if I just declare it and don't instantiate it? So I've not actually stored anything inside this int. I've just declared it, which is bad programming practice if you're then going to use it. But let's see what happens. And I've used it, an uninstantiated variable, and it said it's 0. So by default, something has been stored inside my variable, even though I haven't specified what it is. This is generally bad programming practice if you're going to use it. So just something to be aware of. It will automatically instantiate to be 0 in the case of an int. I think I've said enough on ints for the moment. Booleans, I'm going to talk about that in another lesson. We've already come across it, in fact. It's a variable that can only take true or false. I'll just mention that Booleans are objects, unlike ints, and I'll talk a bit more about that in a minute. And the reason I'm going to leave it is because in another lesson on if statements, I'm going to be talking about comparison and logical operators. We'll be using Booleans all the time. So I'm going to skip Booleans. Numbers I will talk about though. Numbers, unlike ints, contain numbers, but numbers contain numbers with decimal point. Ints only contain whole numbers. And I just mentioned Booleans are objects. Numbers are also objects. Most variables you'll come across, most variable types you'll come across in ActionScript are objects. Like I mentioned, they have a capital first letter, unlike an int, which has a small first letter, although in this case, because it's at the start of the sentence, it has a capital, but usually you'll see it just with a small I. Ints are known as primitive variables. Primitive variables are variables that are more closely associated with computer hardware, how data is actually stored in the computer. Objects are kind of designed to have functions and properties associated with them, so they're more contrived variables. They're designed for specific functions, in this case to store a decimal point after the number, and they can have properties and functions associated with them, unlike primitive variables, which are purely data. I'll talk about the isNaN function in a second as well. So let's try making a number. I can make it like this, instantiate it by telling it what it is there. I can instantiate it in another way. This is specific to objects. You'll have to use this on many occasions with most objects. You use the new keyword and then say the type again, and then in brackets you could either leave that out and not instantiate it, or instantiate it with a specific data, in this case 1.5. So let's just see it working, just so we can convince ourselves that it does. What happens if I don't instantiate it, if I just declare it? As I mentioned, this is bad practice because I'm using an uninstantiated variable. In this case it's saying NaN, not a number. And if you're doing some data validation or something along those lines, you might come across this function isNaN, which can test to see if a number is a number or an NaN. If it's an NaN, it returns true. So I could, if I cut that and paste it in here, so now in output text we'll see the output from isNaN, Let's test and see. And because it is NaN, it's saying it's true. So that's a Boolean output. And I think I'll leave number there and talk finally about strings. So strings are variables that can store sequences of characters. You can instantiate them using double quotes, and most variables can be converted to strings using a technique called casting. So let's have a look at this casting thing. So I'm going to create a string. I could use the new keyword because string is an object, or I could just simply put 1.5 in quotes if I wanted to without the new keyword. So I put 1.5 as a string inside my variable. The reason I want to do this is because I want to demonstrate casting, which is what we've been doing actually the whole lesson. We've been putting a variable type in front of parentheses, and then putting the variable inside the parentheses to change it into that type of variable, the string, so it can be displayed inside output text. I'm going to make a new variable called myNumber. So I'm going to make another number variable, and I'm going to instantiate it straight away as a cast of the string. So the cast here with the string like that. I'm going to put it in my output after I've added 1 to it. So I'm going to perform a mathematical operation on it just to prove that the cast is working. So it started out as a string, and we're converting it into a number, adding 1 to it, and putting it back into a string again using casting. It's going to go control test, and you can see because it's added 1 successfully, our casting has worked. So casting is changing one variable to another, and this is also a very good demonstration of the flexibility of instantiating a variable. I've instantiated it as the output of a cast, but I've declared it in the usual way: var variable name colon variable type. So that's really all I want to talk about in terms of variables. So let's summarize what I've said. There are many different types of variables to store data in Flash programs, including int, boolean, number and string, and there's many more that you'll come across as well. Data is assigned to variables using the equal sign. This is also called instantiation, whereas declaration is where you are first showing that a variable is going to be used in a program, and it's used in a very specific syntax involving the var keyword. So you'd say var, then the variable name you will use, then colon, then the variable type. The instantiation is incredibly flexible. This is simply giving a value to the variable, and there's many different ways you can do it, and it will also depend on whether the variable is of an object type or a primitive type, and the vast majority of variables in ActionScript are of the object type, so you will normally see the new keyword being used. And we will be looking at variables and using variables in all subsequent lessons involving ActionScript.